In today's lesson, we're going to tackle one of the most difficult topics that we will have in our course. It's kind of a long lesson, and I'm going to break it up into different parts. But this is all about polynomial modeling. And what that's doing is when we take a word problem scenario, we're creating a polynomial function, or sometimes multiple functions, that can be used to model the situation. Oftentimes, this is going to be finding a maximum or a minimum of a polynomial, or we're solving for a specific value. Sometimes you'll see this as polynomial optimization, and this is kind of a precursor to some things you'll learn in Calculus 1 if you choose to take that. So if we look at these area type problems, what we're going to be looking for is usually like a maximum area. Here we have a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? So another word for largest would be the maximum. So we're going to be finding a maximum in this problem, and we've done that before with quadratics. So with this, we don't know exactly how much fencing he has used on each side, but we do know that there's a total of 2,400 feet of fencing. So what we're going to do is let this side be x, that side's also going to be x since it's a rectangle, and then the unknown side up top can be y. We don't need a fence here because it's on the river, so we're only going to have these three sides. What we do know is that all of this fencing is going to be used, so all of this together should equal 2,400. So we set that up, and I would say 2x plus y equals 2,400. Now we have two different variables in this, and that's just our fencing equation. What we're going to try to do is create an area, a largest area. So we need to find what is the area equation. So how do I find the area of a rectangle? We just do our length times width, so x times y. The problem is we have two unknown variables. We don't know what x is and we don't know how much y is. So what we do is we use our other equation that we have already set up, and we're going to solve for one of the variables so that we can substitute the expression in. So we want to solve this equation for y, and we would do that by subtracting our 2x over. So it would say 2,400 minus 2x. And because that's what's equal to y, we can take this expression and substitute it in place for y. So that's what we're going to do. We're just going to create a new area expression. Let's do this in the same color. So area equals x times, and now we're replacing y with 2,400 minus 2x. We wanted that because we had an equation earlier that was two different variables, and we needed one that was only one variable. Now this is all in terms of x. If I work that out, I could distribute x and get 2,400 x minus 2x squared. And what we see is we have a quadratic. A quadratic is going to have a maximum or a minimum. In our case, it was a negative 2x squared, so that means it's going to have a maximum somewhere. And we want to find out what would that maximum area be. Now, we're not going to use a graph for this if we can prevent it. All right, so we're going to have to solve this algebraically. I can find a vertex by doing negative b over 2a for x, and then we plug it in, and that will find our output. Now, our output is a. It's not y. We created a new variable to represent our outputs. So what we're going to do, if I solve this, x equals negative b over 2a, you want to pay attention to the order that it's in. This is not in standard form because the ax squared is coming last, but I can still work with it. B is 2,400, so that would say negative 2,400 divided by 2a, and a is -2. We plug that into our calculator, and we get -2400 divided by 2 times -2 should be 600. So x is 600, but we also need to find a, and we just find a by plugging that in. So it was 2400 times x, which is 600 for us, minus 2 times x, so 600 again, squared. We plug that into our calculator. Minus 2 times 600 squared. And we get 720,000. In that case, this was the maximum, the highest point on our graph for the area. So x is telling us what that side length would be, and the area, the output, is 7,200. So the maximum area would be 7,200. Keep our units in place. We're talking about feet. Since this is area, that's square feet. But our question's asking us, what are the dimensions of the field? So we need to find those dimensions. Well, x, we already found. X would be 600. And then we need to find y. Well, y is 2400 minus 2x. So we plug that in. 2400 minus 2 times x, which was 600, gives us 1200. So 600 by 1200 feet. Let's put our units in there. 600 feet by 1200 feet are the dimensions of this rectangle. The next one, a gardener wants to make a rectangular enclosure using a wall as a side and 120 meters of fencing for the other 3 sides. Find the dimensions of the enclosure that will give the greatest area, and what will that area be? So now we're kind of doing the exact same thing, but we didn't get a picture this time. So it's going to be helpful for us to actually draw our own picture. So we have a wall with a rectangle that's got 3 sides. Those can be x and y again. What we know is that we were given 120 meters of fencing. So 2x plus 1y should equal 120 meters of fencing. We want to find the maximum area. So area is x times y for this rectangle. And we need to solve for one of the variables. Now we could solve for x, but that would take a little bit more algebra than just solving for y, because y means I need to just subtract 2x over. So that would say 120 minus 2x. We can take that and plug it in to our area expression for y, because this is our unknown. So a is x times 120 minus 2x. I can distribute to get 120x minus 2x squared. But there's our quadratic that we're trying to maximize. We want to find the maximum area. That's our goal. So it would have a parabola somewhere if we were to graph it that would have a maximum. We can do negative b over 2a to find our x value. So in this case, negative b would be negative 120 over 2a. A is negative 2. We can plug that into our calculator, see what we get. So negative 120 divided by 2 times negative 2 is 30. So the x value is going to be 30. Our output, it's not y, it's A, because we're finding this equation here, this area equation. So I find the area by plugging in 30. 120 times 30 minus 2 times 30 squared. And we just plug that into our calculator. Gives me 1800. So the maximum area is 1800 square meters. If we need to find the dimensions, we know that x was 30. We need to find out what y was. Well, y is 120 minus 2x, so 120 minus 2 times 30 is 60. So it did say find the dimensions of the enclosure that will make the greatest area. That's what those would be. What is that area is 180 or 1,800 meters squared, square meters. So if we work through some of these tips, a lot of these questions you're going to need to kind of draw or sketch a picture to just get an understanding of what's going on. Label those parts that we have and define the variables necessary. So each time I define a variable for something that was unknown, we can identify the quantity that we want to maximize or minimize, and that was A for the two problems we just did. And we can write a maximization or minimization equation. And that's in terms of the variables that we already defined. So we started out with x and y, and we wrote our maximization or minimization equation in terms of x and y. The problem was that it had two different variables. So we set up your equation with the given information, and that's what had the two different variables. We solved the equation in terms of one chosen variable. Each time we did it, we solved for y, but it didn't have to be solved for y. We just needed to know what was the input and the output. We substituted it into our maximization equation. So now that it's only in terms of one variable. It was only in terms of x's, which means that I could take that and plug this into our quadratic stuff. And then we find our maximum or our minimum, depending on what we need. And we interpret our answer in terms of the original problem. There's where our kicker is going to be, because sometimes we're going to run into a problem where we have things that do not work in a real-life domain, or we may get multiple answers, and we'll see what that looks like here in a second. Okay, so this next group of problems is still related to area, but it's about some type of partition. So number 3 says a rancher has 180 feet of fencing with which to enclose 4 adjacent rectangular corrals as shown. So we have a picture and we're just creating these corrals, or like these stalls. Maybe it's for horses. All right, what dimension should be used so that the enclosed area will be a maximum? There's one part of the question. Then what will the area of each corral be? So there's a second type of question. So if we continue kind of like what we did with our previous two questions, that side can be x and this side can be y. Well, if this is x, then all of these partitions are also x, because this is a fence as well. We're creating all these fences, and the top and bottom are also enclosed. So we create 1, 2, 3, 4, 5 vertical parts and 2 horizontal. So that would say 5 x's plus 2 y's. That's the total amount of fencing that we have. Well, we're going to use 180 feet of fencing, so that's going to equal 180. But we want to find the maximum enclosed area. So if we looked at our area, it would be x times y. This time we want to solve for one of the variables. And I'm still going to choose y just because it's a little bit easier. So I would say 2y equals 180 minus 5x. And then we divide by 2. And so 180 minus 5x, that whole thing is divided by 2. I could simplify that to 90 minus 5/2 x if I wanted to. But this is going to be substituted in place of y. So that's what's going to go up here. So now I can replace it and say area is x times 90 minus 5/2 x. And if I distribute, we see that we have a quadratic. It's 90x minus 5/2 x squared. We want to find the maximum area, so same situation we have been doing. That maximum, the x value, is our input, which is still x. The output is our A or area. Excuse me. So then we do negative b over 2a to find the x value. Negative b is still negative 90. Just pay attention to what order that it's written in. 2a would be 2 times negative 5/2. And we see what that's equal to. So negative 90 divided by 2 times negative 5/2 is 18. And that's our x value, but we want to also find the area. So a equals 90 times 18 minus 5/2 times 18 squared. So we grab our calculator again, 90 times 18 minus 5/2 times 18 squared. We get 810. In that case, the maximum area is talking about x times y, which is the whole enclosure. So the maximum area of the whole enclosure is 810 square feet. But if we want to find, and let's just state what those dimensions are. So the dimensions would be x equals 18 feet and y equals, we never really did find y. So 90 minus 5/2 times 18 is 45. So the whole enclosure would be 18 by 45. And that started out with the first part of the question. So what dimensions should be used so that the enclosure or enclosed area will be a maximum? The dimensions would be 18 by 45. So there's part 1. Part 2 asks what will the area of each corral be? That's a little bit different. So there are 4 corrals. If there was a maximum area of 810, we just divide that by 4. So 202.5. So each corral is 202.5 square feet. Okay, number 4. You can pause the video and try number 4 out on your own if you feel like you're ready for it. It's very similar to what we just did with number 3. A farmer has 750 feet of fencing, wants to enclose a rectangular area and then divide it into 3 pens with fencing parallel to one of the sides of the rectangle. If I create a picture of this, I want 3 pens. I could do x times, or x, and x, all those vertical components, and then our top can be y. The bottom's also y. So 4 x's and 2 y's would make up 750 feet of fencing. We want to find the maximum area, which was x times y. So we solve out this problem. So 750 minus 4x is equal to 2y. We can divide by 2. Let's see, 750 divided by 2 is 375 minus 2x. And that's what's going to be substituted into y. Now the area problem is only in terms of x's. So area is 375x minus 2x squared. We find a maximum. All right, that would be x, and the output's a again. So negative b over 2a, it's going to say negative 375 over 2 times a, which is negative 2. So 375 divided by 4. It's going to be 93.75. So it doesn't mean that we're always going to get an integer. We can get something with a decimal. We want to find the maximum area with that. So area is 375 times 93.75 minus 2 times 93.75 squared. Plug that into your calculator to see what you get. So 375 times 93.75 minus 2, 93.75 squared. All right, so it's not an exactly pretty answer, but that's okay. So 17,578.125. All right, so what did the question wanted us to find? It said, what are the dimensions that would provide the maximum area? That is the maximum area. We want to know the dimensions. So we found x already, 93.75. So the dimensions needed are 93.75 feet by, and let's find out what y is. So 375 minus 2 times 93.75 is 187.5. So 187.5 feet. And that's what we were looking for. Okay, last one here, number 5. The area of the partition pen sketched below is 500. So this is slightly different. It didn't tell us how much fencing we have, but now it told us how much area we have. So the area is x times y. But we know what the area is. It told us it's 500. So that's the part that we can set up. We also know the top would be y as well. And every single vertical partition is also x. So there are 1, 2, 3, 4, 5, 6 x's and 2 y's. Problem is we don't have a number here to say, oh, it's this much fencing. So we're going to end up saying it's p. But A is already helping us out. It says write a function to express the amount of fencing P as a function of the side X. So right now I have a function that's P equals, but it's in terms of X and Y, and we only want it in terms of X's. So what we can do is solve the other equation. That's where these tips came into play. It said that we would set up our equation with the given information that will likely have multiple variables. and then solve for one of the variables, one of the chosen variables. Our chosen variable is x for us because it told us to. So here we have 500 equals x times y. If I solve for y, that would say 500 over x equals y. That's what we're going to use to replace the y in our p equation. So p is 6x plus 2 times y. Y is 500 over x. We could simplify that to just 6x plus 2 times 500 is 1,000, so 1,000 over x. That's really all we can do because we can't combine these. They're not exactly like terms. Now part B wants us to find if the partition's length are 13 feet, what will be the total amount of fencing needed? So that's saying if these are all 13 feet, the partition lengths. So now x is 13. Well, I know an equation for it now. 6 times 13 plus 1,000 divided by 13. And that's going to give us our amount of fencing because P was our total amount of fencing. So let's plug that in. 6 times 13 plus 1,000 divided by 13 is 154 roughly 92. So we need a total of 154.92 feet of fencing.